f is a function from a to b, where the domain A is not empty. This function f is constant if there exists b, small b in big B such that for all x in the domain, f of x equal to small b. For example, the function f from R to R, send all the points x in R to 0 is constant. So there exists b equal to 0 such that for all x in R, f of x equal to 0. Be very careful here with the quantifier. The orders of the quantifiers matter. So there exists b in B such that for all x in A, f of x equal to b. This one is different from for all x in A. There exists b in B such that f of x equal to b. These two are different. This small b here is defined there exists b such that for all x in A, they send to the same point, f of x equal to exactly this b. Okay, so for the first part, prove that f is constant if and only if for all g function from A to A, f dot g equal to f. This is an if and only if statement. We need to prove two directions. The forward direction, we suppose that f is constant. We need to show that for all function g from A to A, f dot g equal to f. So recall that f is constant means there exists small b in B such that for all x in A, f of x equal to b. Now let's pick arbitrary element g. We want to show that f dot g equal to f. Okay. So these two, we need to show two functions, f dot g and function f are equal. Function f is a function from A to B. Function f dot g is a composition of f with g. It goes from A to B, so the domain is A, codomain is B. So f and f dot g have the same domain and the same codomains. We only need to show that for all x in A, f dot g of x equal to f of x by a theorem we know before. So now let's pick x in A. We will show that f dot g of x equal to f of x. Now we compute this first. F dot g of x is by definition the composition f of g of x. G of x is a point in element in big A. So for any element in big A, f will send that element to small b. Therefore, f dot g of x equal to small b. Again, small b is f of x for any x in A. This is because f is constant function that we know from the hypothesis. And therefore, f dot g of x equal to f of x for all x in A. And therefore, f dot g and f, the two functions, are equal. So we finish the forward directions. Now we prove the backward directions. Suppose that for all g from A to A, f dot g equal to f. We will show that f is constant. Since A is non-empty, this set is non-empty, there must be an element small a in big A. Okay. Now we have this. Since f dot g equal to f is true, this is true for all functions g from A to A. This must be true for a function I call it g naught. G naught from A to A that send any point in A to small a. Small a is an element in A we define from before. The A space of A, we just pick arbitrary A in A and fix it. So we fix this small a. And we define function g naught to be the function, actually to be the constant function from A to A. Send any x to this small a. Okay, we know that the hypothesis f dot g equal to f is true for all g from A to A. This must be true for g naught. So we have f dot g naught equal to f. For g naught is a function from A to A, send any points of A to small a. Okay. So now what do we need to do? We need to show that f is constant. So here's how we show it. We will show that there exists a point, an element, so f from A to B. there exists an element in big B, which is the element f of A, such that any point in the domain A, f sends that point x to f of A. So that's what we will do. We'll show that for all x in A, f of x equal to f of small a. We call that small a in big B and small a defined just because we fixed small a in big A before. Okay, f of x equal to f dot g naught of x. This is because f equal to f dot g naught. Okay, f dot g naught of x is f of g naught of x. This is by definition of composition. Now g naught of x is a, because we define the function g naught to be this constant function. So g naught of x for all x in A must be equal to a. So g naught of x is a. F of g naught of x is f of a. F of a is a fixed point that in B. That we fixed this point A before, so f of A is a point in B. For any x in A, f of x equal to f of A. By definition of constant function, f is constant. So that's how we prove the backward directions. Therefore, we prove the exercise.